Hello, Technograhis. You must have gone through the video lecture on Lighthouse project at Indore, where we have used a hybrid steel structure system with cement EPS panels. In the e-module, we have also given you enough reference material in form of films, lectures, presentations, books, certificates, circulars, etc. And it is recommended that you all must go through them and use them frequently. This collection of reference material at one place is unique, and you won't be able to get that kind of information anywhere else. So please keep a copy of it. Having gone through the video lecture, there must have been several doubts, queries in your mind. In order to answer your queries, what I have done here is that based on my experience and interaction with various stakeholders at various platforms, I have created a section of FAQ, which I'm going to present to you now. Most of the questions or queries asked by different stakeholders or professionals can be divided into these 8 broad areas: cost, structural performance, functional performance. What about joints and connections? Do we have design aids, codal provisions, schedule of rates? Can we do additions and alteration? What about maintaining the services? And do we have capacities of professionals, agencies, and workforce? So I will try to explain you all of them one by one. But before that, let me just give you the statistics of LHP at Indore. The project is of 1,024 houses with social and the basic physical infrastructure. The towers are in the configuration of steel plus 8 stories, and the total project cost is 128 crores. So the first and foremost question comes to mind, that what is the cost per square feet if we compare it with the cost of conventional construction. And when we are talking about conventional construction, we are talking about RCC frame construction, cast in situ, or load bearing construction. Since it's a high-rise structure, so it need to be compared with the cast in situ RCC frame construction. So the project at Indore, the cost per DU with this technology, with this hybrid technology, comes to 12.5 lakh rupees. Whereas if we calculate the cost per dwelling unit using conventional technologies, and what we have done is we have used plinth area rate of CPWD, then it comes to 14.2 lakh. So cost here is 12% cheaper. So the cost is cheaper than the cost of conventional construction, which is cast in situ RCC frame construction. But at the same time, let me also tell you that cost depends on number of factors, such as what is the size of the project, what is your location, what are the geoclimatic conditions, whether it falls in high seismic zone, what about soil strata, whether it falls in black cotton, whether it has black cotton soil or marshy land, or water table is high, what about availability of materials in factory, if you are constructing in the vicinity of the factory where the technology is being manufactured, then cost may be less. Then accessibility to the site is also quite important, because you need to transport these systems or components to the site. Also, another very important thing when we talk about cost is a critical mass. Critical mass is something which is also known as economies of scale. So what should be the minimum built up area or minimum number of houses, so that technology become comparable with the other prevalent construction practices as regards cost. Okay, so also remember that once right now these technologies are at the nascent stage, they are being implemented in few projects, but once there is demand, and once we have several factories, and once the components are being produced in factories, then the technology is mainstream, the cost will automatically come down. Okay. Also, the technology used here comprises of two things. One is a steel structural frame, which is hot rolled steel structure frame of built-up sections, and and the walls are EPS cement panels. Right now, in this project, EPS cement panels are recommended as non-load bearing applications. But these panels can also be used for infill wall panels, floor and roof panels with RCC and steel construction. And if we want to construct a house of single story with these panels, the cost will definitely come cheaper. At present, the technology is recommended only up to one story or a single story as a load bearing panel. But otherwise, if you want to use it with steel or RCC construction, then you can use these panels as infill panels or non-load bearing applications. Another thing about these panels, you might have seen during my video lecture that it is a dry wall construction. And when we are saying dry wall construction, that means that while erecting these walls, no water is required. You don't require any curing, and these panels are made in the factory, so they are quality panels and they are durable as well. So whenever we talk about cost, always remember that these technologies give you added advantage in terms of resource efficiency, environment friendliness, cost effectiveness, and enable faster construction. Another important thing is energy efficient. Being EPS panel, the embodied energy is less, and what you get is energy efficient construction system. Now let's move to the structural performance. Whether the structural performance with these kind of hybrid system or with these EPS panel will be better than your proven RCC frame construction, the answer is yes, because steel is a good material to start with. It's very ductile and it goes well when we talk about disaster resistant construction. So this combination of steel structural system with lightweight panels, also known as composite or mixed construction, is alternate construction practice, and to achieve high speed, and this lightweight construction enables improved structural performance because also you have reduced load demand, and because of this reduced load, your foundation design is economical. The sizes of your structural frame will be economized, and at the same time, requirement of steel and will be brought down because you are using lightweight panels, and thereby you can achieve overall economy. Okay. Secondly, the steel construction, when we are talking about these built-up sections, and nowadays we are getting tubular as well as pressed steel sections, so they have considerable improved structural performance. So we can say with the confidence that with these kind of system, the structural performance is improved. As you know, in industrial structures now, most of the industrial structure all around the world, they are being constructed with pre-engineered structure. And pre-engineered structures means your structural grid is made in the factory. The sections are made in the factory, assembled at the site, and in fact, you have trusses, steel trusses, which are again made in the factory, and all you have to do is assemble them at the site, put profile and start using it. Okay, and it is a universally accepted practice world over the pre-engineered construction. So steel construction offers a better structural performance. And this also I covered that lightweight provides better seismic resistance and reduced load on foundation. Another question comes being steel and being these panels, are they fire resistant? So yes, you get better fire resistance because nowadays steel can be coated with different kind of protective coatings, enabling it fire resistant. Durability, improved durability, and being steel and EPS panels made in factory, you can easily maintain them. And because of durable, easy maintainability, this all lead to superior structural performance. Let me also tell you that structural performance is something which is also associated with good workmanship, quality control, and assurance, and proper execution. So no technology can be taken for granted for better structural performance unless you do proper execution with proper quality control and assurance and good workmanship. Now let's talk about functional performance. Again, the question being asked is, being thin sections, are our buildings thermally efficient? What about acoustics? What about fire? What about durability and compatibility with conventional finishing items? So as you can see, these EPS panels, they are made with special concrete, which is known as elevated concrete. And elevated concrete is nothing but it's a lightweight concrete, which comprises of your cement, sand, fly ash, and EPS. EPS is expanded polystyrene granite balls. So these balls are added with the cement, mixed with the cement, sand, fly ash in slurry state, and so as to produce these core of these lightweight cement EPS panels, and the outer faces are of fiber cement board and calcium silicate board. So the core being lightweight and being made of foam concrete or this elevated concrete, it offers excellent thermal insulation property. And thermal insulation is measured in terms of U. So U value of cement panel is very less, making it thermally efficient. Also, once you have less U value, so naturally the energy demand of your building is considerably reduced due to this due to better thermal efficiency. And so in the long run, you get low life cycle cost, and energy consumption of your building for heating, ventilation, and for air conditioning get reduced. And so the overall demand during the life cycle of your building, or during the service life of your building, gets reduced. Fire rating, again, these panels are factory made, so these wall panels need to comply with national international code regulations. And as regards steel structure, they also have to comply with the national international code regulations. Durable, excellent surface quality, texture, easy maintainability makes this panel and this hybrid construction quite durable and better than your conventional cast in situ RC frame construction. There's another very important thing when we talk about functional performance is compatibility with the existing items related with services or finishing items. To talk about doors, windows, tiles, laying taps, sets, sewerage lines, and all these things. So they have excellent compatibility with conventional finishing items. Joints and connection, steel, because we are using here steel. There are two kinds of connection here. One is steel to steel, and another one is steel to panel. So steel components can be joined through mechanical connectors and comprising of angle plates, channel bars, anchors, fastener, bolts, toggle bars, etc. So you can connect to have shear, movement resting joint, or shear joint. You can connect the beam columns through the web, through the flange, through gusset plates, either through welding or either through nut and bolt. So all kinds of connection exist, and these connections can be properly engineered, designed, and detailed. Sometimes you can also do the joint and fill it with the in-situ mortar, so in a composite construction. Like here in Indore, what we are doing is, once we erect the frame, then slab is being laid with deck sheet and reinforcement, and then the screed concreting is done, and those walls are connected with the those double the reinforcement in the screed is connected with the beam and column, so making it a monolithic connection and ensuring the structural integrity. And these joints with mechanical devices and fasteners have been developed, to avoid failure of connection by shearing studs, pull out of anchor rods, brittle failure of belts, and bolted threads when subjected to lateral loads. So all these connections are also tested for earthquake loads or lateral loads, and so that you avoid brittle failure and avoid deconnection by shearing of connections. So they can be properly designed. There is absolutely no problem as far as structural system is concerned. And next question comes that how do we connect the EPS cement panel with the boundary elements, which is either of RCC beam column or steel beam column. So for steel beam column, you can put the angles, you can put the base plates and weld the plates together, or through nut and bolt, you can put through nut and bolt, you can connect cement panel with the steel panel. In RCC, it is very easy because you can do it through dowel bars. So what is being done, because you have a core, lightweight core, so a dowel bar at 45-degree angle is inserted in the RCC beam and column as well as in this panel, so as to connect connectivity. And once it is inserted or in an already drilled hole, then those holes are grouted with non-shrink grout. also making it monolithic connection. So with RCC, you connect it with the dowel bars, and in case of a steel frame, you connect the cement panels through mechanical connectors using anchors, bolts, angles, etc. Also, let me also clarify here that whenever we do joint and connection, each joint and connection, depending upon the requirement, need to be properly designed and detailed. Whether it is a shear connection or moment connection or both, it has to be seen and then it has to be designed so as to avoid the failure of connections in future and during the service life. Next question is design aid code provision scheduler do we have? So first of all, let's talk about design aid. So thanks to the softwares being made available all over the world nowadays for carrying out detailed structural analysis, linear, non-linear, static, dynamic, eigenvalue analysis, time stream, frequency domain analysis. So multitude of softwares are available now. Some of them are listed here: ETAP, SAFs, StatPro, Abacus, and you can do 2D analysis, 3D analysis. Another good news is now these softwares are customized for Indian requirement and are being customized for as per Indian code languages as well. So any software can be used, a model can be created, and you can do the structural analysis. And once you do the structural analysis for design, already we have the code which we call the Bible of steel construction, that is IS 800. So all of you must remember that whenever we are doing a steel construction or steel frame structure, always refer IS 800. So IS 800, once you do the analysis, will help you in designing the members, steel members, structural members, as well as help you in joints and construction. Then for concrete, if you're doing it with concrete cement panel you are using, and with EPS cement panel, then you can use IS 456. Then National Building Code is compilation of all the codes, so that is also must. And NBC also gives you in brief something about these technologies. As regards schedule of rate, yes, we have for the cement panel schedule of rate is available in ESR, CPWD, and also remember that in case there is non-availability of Indian standard, we can always refer international record as allowed by Bureau of Indian Standard. Also, the Government of India has authorized BMTPC, and in fact there is a mention in the National Building Code as well that for new technologies, BMTPC's issued performance appraisal certificate can always be referred to for designing or for implementing the project or for construction of any project using new technologies or sustainable materials. So we have, if we don't have Indian standard, then you can use international standard, and also you can refer BMTPC issued performance appraisal certification. Also, this technology has been approved by CPWD, as well as it is one of the shortlisted technology, as we all know, under Global Housing Technology Challenge. India, Indian standards, if we talk about, India has a history of having, exhaustive codes on all the engineering, issues or engineering problems, or for design, for analysis, for materials and all. So just for you, a list, if you want to calculate the load, the most important code is IS 875. It comes in 5 parts, and, and it covers all the loads except earthquake load. So for earthquake load, you have to refer 1893, part 1, which is very important, which gives you how to calculate lateral load depending upon the joint size and other specifications. Okay, for structural steel, the most important code is IS 800. For light gauge steel, IS 801, and for connections and all, you can see there are the other codes which are written here. Then for composite construction, there is another code 11384, which is also quite important. Then for RCC, IS 456 is very important. Apart from this, for steel, the reinforcement bars, you can use this 1786, which gives you the property of steel bars, which is to be used. For foundation, again, the foundations are conventional. So for conventional foundation, for each kind of foundation, depending upon soil strata, you can have whether you can have shallow foundation, or you can have deep foundation, or you can have raft foundation. So deep foundation means pile foundations. Okay, so for each kind of foundation, we have a dedicated code, and those codes are written here. For example, for raft, you have 2950, whereas for shallow foundations, isolated footing and all, you have 1080 code. Additions and alterations, because these are pre-engineered buildings, so addition and alteration at the later stage is difficult to do, but it is not that it is impossible. It but always seek the help of experts, because getting it done by a petty contractor will not help. And therefore that is why we advise, whenever you are using a new technology, always keep a manual of that technology, because later on if you want to change something, you need to do it through that manual, or through the help of the expert, because these buildings are pre-planned, and everything is pre-engineered in the factory, and properly, through a sequence it is being constructed. So therefore additional alterations are difficult to. As regards cement, wall panels, infill wall panels, because most of the services go through the cement EPS panels. So these panels are, as I told you earlier, they come in the width of 300 millimeter, and they are connected together through a tongue and groove and slide and log arrangement and double bars. So these dry wall panels can be easily removed, and then you can carry out the alterations if required. But again, you need to seek the help of experts. Maintenance of services, again, being drywall construction, the panels can be removed, and the damages, leakages can be attended to some extent. But again, difficult to do, and you require skilled workforce for the services. So the good practice is that always do a regular preventive maintenance, as like checking of lines, continuous water flow, cleaning of clogged drain. These kind of regular preventive measures will help you maintain the services during the service life of building. Otherwise, at a later stage, doing at a later stage, attending to damages or leakages is difficult. Okay, and also during the installation or during the construction of the building, we need to do, properly install the services, including jointing, because so that at later stage they don't show signs of distress, damage, or leakages. Also, in such type of construction, remember, because it is a steel and cement panel, so you have to, wherever you have joint of steel and the cement panels, you have to properly plug all the joints, because at a later stage you may get you may have ingress of water during rainy seasons. So proper cladding and proper connection of joint and plugging all joint is also necessary, so as to avoid at a later stage damages. Capacities in terms of professional agencies and workforce, yes, for steel is being taught in curriculum, steel building construction, but this kind of innovative hybrid construction, there are few professionals as regards these new technologies, but concerted efforts are being made at the Government of India level, and we are also running a course called Navriti, through which we are trying to build capacities amongst professionals regarding these technologies. And this technology is also a step towards capacity building, and through these technology also our objective is to inculcate the knowledge about these new technologies, so that you can implement them in your future endeavors. Also, we are trying to get these technologies included in the academic curriculum of academic and technical institutions. And once they are included in the academic curriculum, then the students of architecture and engineering can be taught about these innovative construction technologies. As regards agencies, there are few agencies working with requisite experience to execute such kind of large projects. But in the wake of Atmanirbhar Bharat and Make in India call given by Honorable Prime Minister, there are more and more new entrants, startups, entrepreneurs, industries. They are joining the construction sector, and they are working in the area of these innovative technologies. So in times to come, we will have good competition, and again, it depends on demand. If there is demand, then more and more agencies will come forward and do construction using these new technologies. Last but not the least, you always require skills, a special set of skills when you're dealing with steel and this kind of hybrid construction. So trained skilled workforce is necessary, but they can also be imparted on-site training some of the organizations or some of big agencies, what they do is they train the manpower before starting the project. Okay. Also, the unskilled labor which you are employing in these projects, they also required the little training, on-site training, so that they can work in the project effectively. With this, I come to the end of this FAQ. I hope I'm able to tell you something about the doubts which you might be having in your mind. Although I've tried to cover most of the things, but in case you have more questions or if you seek more clarification, you can always write to me on my email ID ska@bmtpc.org, and to the best of my capability, I will revert back and try to answer your queries. Thank you very much.